The space agency recently said that it had given Elon Musk's company SpaceX a contract for NASA launch services to launch the Nancy Grace Roman Space Telescope. NASA hopes that the Roman Space Telescope will shed light on the secrets and mysteries of dark energy, dark matter, and other astrophysics and planetary science topics that have stumped experts for years. Would you like to know more about it? Then stay tuned. Welcome to Techmo. In today's video, we are going to discuss the latest news about the SpaceX FALCON Heavy rocket, which will launch NASA's Roman Space Telescope. After months of testing, the James Webb Space Telescope, which is the biggest telescope ever put into space, is now in use. It's a big step forward for astronomy and will help us learn more than ever before about the universe. It will focus on astronomy in the infrared range. Infrared is useful because it lets you see galaxies that formed right after the Big Bang, which are very far away. The people who work on Webb just put out the first scientific pictures taken by the telescope in infrared light, and they are amazing. We have never seen views of our universe like this before, whether in infrared or invisible light. These targets included galaxies, nebulae, and even an exoplanet. Webb's first pictures are amazing, but now the question is, what is next after Webb? What space telescope can beat Webb? The Roman Space Telescope, or Roman for short, will be an infrared, invisible light space telescope that will operate at the Earth-Sun Lagrange point 2 or I2. This allows the telescope to be far from any light reflecting off the Earth or Moon, but also to be close to Earth for launch and communication purposes. Roman isn't bigger than Webb, or really more powerful either. It will take a different approach to astronomy. Instead of being a super precise and zoomed-in telescope, Roman is a telescope with a wide view. This means that Roman can see big parts of the sky at the same time. More specifically, it can take pictures 100 times larger than Hubble's field of view with the same accuracy as Hubble's infrared camera. Dr. Jonathan McDowell, an astronomer at the Center for Astrophysics, also works on the Chandra X-ray Observatory, which is one of the most powerful X-ray space telescopes ever flown. Roman, named after NASA's first chief of astronomy, Nancy Grace Roman, will be able to compare to Webb, which has a 6-meter mirror for comparison. This mirror is not that big. Most of the time, a bigger mirror lets you see more detail and see fainter things. But Roman doesn't mind that he doesn't have a big mirror. It doesn't look for small things all that hard. We'll talk about this in a little bit more. There will only be 2 instruments in Roman, the coronagraph and the wide field instruments. The coronagraph is a technology demonstrator, and a chronograph is a device that blocks or cancels out the light from a star so that you can see the planets around it. Often, this means physically blocking a star with something that cannot be seen through. To put it simply, Roman's coronagraph won't just block the light with an opaque object. Instead, it uses a complicated arrangement of bendable mirrors to do this. With light blockers and software, the instrument will be able to use destructive interference to make a star's light go away. Then it can look for planets around the now hidden star. Coronagraphs have been to space before on the Hubble and James Webb Space Telescopes. Even though the James Webb Telescope is pretty new, coronagraphs have been used on it. Roman's coronagraph will be 2 to 3 orders of magnitude better at seeing planets around a star. Dr. McDowell explained this extreme power by saying, "You should be able to see a contrast of 1 in 1 to 10 million. That means that if there is a star with a brightness of 10 million and a planet with a brightness of 1, you can see the planet next to the glare of the star, even if they only are 0.3 arcseconds apart." On board, the coronagraph Roman will also be able to split the light coming from those faraway planets to find out what gases are in their atmospheres. Only at the beginning of the mission will the coronagraph be used to show off the breakthrough instrument. If everything goes well with it, it might be put into service after about a year and a half of the mission. The wide field instrument, which Roman also has, is the most important tool for the mission. It is made to take pictures of large parts of the sky at once. It will take pictures of targets with 18 large sensors, each of which will make a 300 megapixel picture. Dr. McDowell explained this in an easy-to-understand way. And the main camera is also easy to understand. It is the same thing as using force. Huge field of view, lots of pixels. So let's see what we can see. It has a set of filters that let it measure exactly how much light is in different wavelength and color ranges. There are 8 different filters for the camera, and each one only lets a certain kind of light through. So, the camera will be able to see from blue light to almost infrared light. It cannot see as far into the infrared as Webb can, but it can see a lot more visible light. Due to improvements in camera and mirror technology, the wide field instrument will be able to see over 100 times more of the sky in each picture than Hubble. But what will Roman do with all of this power? What does it look into? Well, Dr. McDowell gave us some information by saying that Roman will be a great help in trying to figure out what dark energy is. Dark energy is a theory that could explain how the universe's mass is spread out. We can't quite see what it is, but we can see how it affects things. Gravitational lensing is a great way to find out more about dark energy. This happens when a large object, like a star or a galaxy, uses its gravity to bend the light from another object behind it. In fact, one of Webb's first pictures of SMACS 0723 or SMACS 0723 shows this effect happening. With their small fields of view, many other telescopes can do this, but only on a small scale. With Roman's large field of view, this effect can be seen on a huge scale. Gravitational lensing can also bend and brighten the light from other planets, so this method will also be used to look for them. The main goal of the proposed joint dark energy mission, which became Roman in the early 2010s, was to study the effects of dark energy on the universe. Dr. McDowell also said something else very interesting about Roman. Another cool thing about it is that it can slow down very quickly. In just a few minutes, it can move to look at a different part of the sky. He then talked about why moving quickly can be helpful. He said, that's an important piece of science if you want to look at a supernova that has just gone off, or a gamma ray burst that's just gone off, and see, or a fast radio burst, and see the galaxy that's coming from, and see if you know the star that exploded. That's the counterpart to what you're seeing. It's not clear what will happen to space telescopes after Roman. The Decadal Survey, which is basically a meeting of scientists to decide the US spaceflight goals, is set to launch no later than May 2027 on a commercial rocket that has not yet been named. Each decade has recently called for a 6-meter diameter ultraviolet, visible, and infrared observatory to be launched in the 2040s. This telescope, about the same size as Webb, would be a true successor to Hubble because it could see in all of Hubble's wavelengths of light. The closest proposed mission to this idea is LUVOIR B, an 8-meter telescope that would also unfold in space like Webb. The future of space telescopes looks very interesting, and whatever telescope ends up being would be a great help to astronomy. So that's all for today's video. If you like this video, give it a thumbs up, and if you want to watch more videos like this one, hit the subscribe button and turn on the notifications so that you will always be notified.